particular capital accumulation within the solar framework. Economic growth is important because it raises a nation's standard of living. In this lecture, you will learn how a country's standard of living depends on economic growth within the solar closed framework. Why economic growth matters. Let's look at some statistics so as to get a feel of the importance of economic growth. 20% of all infant mortality are concentrated in 20% of the poorest nations. In Pakistan, for example, 85% of the population live on less than $2 per day. That's staggering. Famine is also concentrated in poor countries. Economic growth has serious implications for these statistics. If we can figure out a way to get poor countries to grow, we can solve some of these staggering statistics that we are seeing popping up in poor countries. Let's look at a graph to get a further understanding of the importance of economic growth. This graph shows that countries that have high income tend to have low poverty. Take South Korea, for example. South Korea has income per capita of about almost 20,000 US dollars, somewhere within the region of 18 to 19, 20,000 US dollars. But South Korea has almost zero poverty. The point is, countries that have high income tend to have relatively low poverty rates. Now, let's build a solar framework, and from this solar framework, we're going to tease out the implications of economic growth. One of our key variables is capital. K. Capital will increase if investment increases, and capital will decrease if depreciation increases. Labor is our second key variable within the solar framework. Labor, denoted by L, will grow at the rate of population. And we're going to use a consumption function, it's a bit simpler compared to the consumption function that we have used in a previous class. Let's look at the production function. Our production function is also familiar from previous discussion. Here we do a little bit of algebra and express our production function as output per worker as a function of a capital per worker. So Y is our output per worker and Fx is our capital per worker. So this is our basic production function that we're going to use in our solar framework. When we work through the algebra, we express our aggregate production function in per worker terms. Now we can represent that production function graphically. On our x-axis we have capital per worker, our y-axis output per worker. This production function shows that at low levels of capital per worker, an additional unit of capital is relatively productive. But at high levels of capital per worker, an additional unit of capital is relatively unproductive. In other words, the production function exhibits a diminishing marginal product of capital. So let's move on to another key component of our solar framework. In this national income identity equation, income equals consumption and investment. And again, we express national income identity in per worker terms. So output per worker equals consumption per worker and investment per worker. So consumption per worker and investment per worker constitute the distribution of output per worker. So we can move now to the consumption function. The consumption function, as we suggested before a few slides ago, is a simple consumption function. We have a saving rate and our output per worker. So the consumption function equals 1 minus the saving rate times output per worker. Now, for our saving and investment function, it's important to note at this point that the economy is closed. Therefore, saving equals investment. Again, when we work through the algebra, the end product here is our investment per worker equals saving rate, output per worker equals saving rate times capital per worker. Again, because the solo framework that we are working with is a closed economy, investment equals saving. So let's put all the pieces of the solo framework together. That is output, consumption, and investment. Here we have our two important schedules. We have the production function schedule and the investment schedule. Now, output is distributed again between consumption per worker and investment per worker. The key intuition of this graph is that as capital per worker increases, output per worker increases, and therefore consumption per worker and investment per worker increases. So we can, from this graph where we represent all the key equations of the solo framework, we can tease out the implications for economic growth. So a key question at this point is, what are the implications for economic growth of all these key components of the solo model? There are at least three key implications for economic growth from all those components of the solo framework that we have developed. First, countries must raise their capital stock in order to generate high levels of income. Second, more of that high levels of income must go toward investment as opposed to consumption. third, investment must take place with with more efficient, more efficient technologies in order to maximize economic growth and therefore welfare of a nation. So those are the three key implications of the Solo framework that we have developed so far.